Ignition sequence start.
Good morning, and welcome to a view of the International Space Station Flight Control Room at NASA's Johnson Space Center. You're watching the flight control team members as they keep an eye on the space station systems and stand by to work with the Expedition 65 crew members on science research and station maintenance. The station crew members got a new commander this week, and then 3 new crewmates who arrived in a Soyuz spacecraft. 2 of them there on a commercial contract with plans to shoot scenes for a movie.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Kayla LaFrance. There's a lot of change on board the ISS, with new crews arriving and others preparing to leave.
Tomaya, you've been an amazing crewmate, and you're going to be a superb commander. So congratulations.
On Monday, October 4th, European astronaut Thomas Pesquet took command of the space station from Japanese astronaut Aki Hoshide in the traditional change of command ceremony. Pesquet became the 4th European astronaut to command the ISS and the first French astronaut to hold the position. Pesquet will remain as the commander of the orbiting laboratory until November, where he will pass the command role over to cosmonaut Anton Skaplerov before he returns with his Crew 2 crewmates. Then on Tuesday, the crew on board the space station welcomed 3 new crewmates when the hatches opened for the latest mission to the orbiting lab.
Engines at maximum thrust, fuel and tower separation, lift off.
3.5 hours after its launch from the Baikonur Cosmodrome, the Soyuz MS-19 cruise ship successfully docked at the station's Razvet module. Veteran cosmonaut Anton Skaplerov, on his 4th flight into space, commanded the spacecraft and was joined by Russian spaceflight participants who are making their first flights into space. They will spend 12 days on the space station, filming segments for a movie titled Challenge, under a commercial agreement between Roscosmos and Moscow-based media entities. Last week, NASA and SpaceX set the launch date for the 3rd commercial crew spaceflight aboard a Crew Dragon spacecraft. NASA's SpaceX Crew 3 mission will carry NASA astronauts Raja Chari, Tom Marshburn, and Caleb Barron, as well as European Space Agency astronaut Mateusz Maurer, aboard a Crew Dragon spacecraft on a Falcon 9 rocket to the space station. The mission is scheduled to launch no earlier than Saturday, October 30th, from Launch Complex 39A at NASA's Kennedy Space Center in Florida. Be sure to follow along on NASA TV, nasa.gov, or the NASA app as we share pre-launch interviews and briefings leading up to our full live coverage of launch and subsequent docking. And that's Space to Ground for this week. Thanks for watching. We'll see you next week.
1, 2, 3, Expedition 65! Thanks.
Recently, the space station crew woke up another flying robot to add it to the fleet of them being tested to see if they can do simple tasks that will help humans in space. Astronaut Chris Cassidy demonstrates the flying robots being developed by NASA's Ames Research Center.
The unique thing about this particular one on the right docking station, it goes in upside down. Went and got some snacks, some nuts and some hot chocolate. So the scientific team is in California, the payload control center is in Huntsville, and of course I'm here. So we've got 3 different locations, we're all working together.
The International Space Station is well known as an orbiting laboratory, but its mission also includes preparing us for future exploration, improving life down here on Earth, and encouraging commercialization of space. In that area, one of its great success stories is a product called CubeSats.
Think of the International Space Station, and most likely you imagine an orbiting laboratory where scientists observe how plants, materials, and humans react to microgravity conditions. But during the past decade, the station has also served a very different role, that of being a business incubator. And this is one of its star products, the CubeSat. The CubeSat is one of many types of satellites now found in space. It is one of the smallest. One unit is a compact 10 by 10 by 10 centimeter cube and is commonly referred to as 1U. And it can be deployed for a fraction of what its larger cousins cost. Early small satellites launched from the station were literally thrown into space by Russian cosmonauts. In 2012, crew members began utilizing the airlock in the Japanese Kibo module to deploy up to 6U of CubeSats per airlock cycle. And not long after, the American company NanoRacks built and began operating an even more robust deployer on the station, capable of launching up to 48U per cycle. That changed everything. Mike Reed is the manager of Space Station Business and Economic Development at Johnson Space Center. He notes how one of NanoRacks' first customers, Planet, leveraged the new launch capabilities aboard the space station. Planet wanted to take high-resolution photos of Earth. While you can take pictures from the space station, your coverage is limited by the station's orbit. With multiple CubeSats, however, you can position them to cover almost any point on Earth. In a relatively short time, Planet deployed several generations of CubeSats from the space station, proving the viability of their technology approach and their business model. With these successes, Planet quickly expanded to an operational fleet of over 150 satellites deployed using commercial launch providers. This fleet gives them the ability to image the entire Earth's landmass every day. Planet's imagery is now in high demand by companies and governments who use this big data in the fields of agriculture, forestry and land use, mapping, and disaster response. Within a decade, the company has grown from a true startup to employing nearly 500 people. Multiple companies are now building small launch vehicles specifically to deploy CubeSats and other small satellites into low Earth orbit, for use in a variety of ways for companies as well as students and nonprofit organizations. CubeSats are being used to provide internet services to even the most remote regions of the planet. They're helping build better weather and climate models to improve weather forecasting. They're enabling text messaging for your phone around the globe, even without a cell signal. CubeSats are also leaving the planet. The first and second interplanetary CubeSats accompanied NASA's InSight lander on its recent mission to Mars, relaying data about the spacecraft as it entered the planet's atmosphere. Some CubeSat missions will serve as pathfinders to help map the way for the Artemis missions to the Moon. And 13 CubeSats will launch on the first mission, Artemis 1. Reed concludes with this observation. Today, more and more, a single large and expensive satellite is being replaced by one of the newest members of the satellite portfolio, a flock of small, less expensive, yet very powerful CubeSats. Affordable access to space has broadened the station's capabilities in a way that, frankly, was never envisioned. However, that access has enabled CubeSats to become a sustained commercial success, contributing significantly to the growing space marketplace. For more science and research from the International Space Station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.
The effort to design and produce the hardware we'll need to explore the moon on Artemis missions isn't restricted just to NASA engineers and scientists. We have a program designed to reach out for the particular expertise of today's college students for their help in developing the software and technology that'll be needed to create those new tools. Take a look at what the SUITS program is doing, not only for exploration, but for student education.
NASA is building exciting new technologies to help astronauts explore the moon, and it is tapping into the unique perspective of today's college students to contribute research to those new tools. Today is test day. NASA engineers are helping evaluate software designed by students. The task is to see how this technology can help during a space mission. It's the culmination of the students' hard work on the program known as SUITS.
So SUITS is Spacesuit User Interface Technologies for Students. What that means is we're having students design a graphic user interface for the suit helmet bubble. You know, a heads-up display would be something that's fairly far out from your face, so maybe a couple of feet or further. What the students are using is a head-mounted display, and we really kind of refer to that as a heads-on, like it's on the head, and so it's only maybe a half inch or so away from the eyes, and they wear it like goggles. It allows them to not only see the real environment in front of them or around them, but also it overlays text or imagery in front of their eye so that they see that on top of the real environment.
Seeing both the graphic overlays and the real environment is called augmented reality. The challenge for the students is to use this technology to be of help during one of the most difficult tasks encountered by humans in space.
So an EVA, or an extravehicular activity, a fancy word for a spacewalk at NASA, is typically a crew member leaving their vehicle, their spacecraft, in a pressurized suit. EVAs are oftentimes, if you ask an astronaut, they'll say that they're much like doing brain surgery and running a marathon at the same time. What we do with suits is simulate this intense EVA environment, but we then introduce an augmented reality display in harmony with the audio feed that comes over the loop from mission control.
Astronauts today don't have augmented reality visible inside the space helmet during an EVA. They rely on their training, mission control, and in some cases a small booklet known as a cuff checklist should they need more information. The SUITS project challenges the students to look forward and wonder, what if astronauts could access data using this technology? What would it look like?
Yeah, I think SUITS is an awesome program and asks teams to create some kind of user interface. It can be virtual reality or it can be augmented reality, but the goal is to basically build a tool that astronauts can use when they're doing space operations.
Students come up with ideas that run the gamut of EVA activity, such as operating complex equipment, cataloging a lunar sample, or navigating to a remote location.
Our main goal was to build a minimalistic and unobtrusive interface that's easy to use, so we made sure to develop exclusively natural inputs like hand gestures and voice command to control the EVA system.
NASA mentors and academia sponsors help the students achieve their goals.
It was extremely constructive altogether. I would like to say that we riled each other up positively, in the sense that we were able to achieve greater things, because at every meeting we would say, hey, what if we do this? Hey, what if we do that? Hey, wouldn't it be awesome if? So overall, we were positively reinforcing each other's interests.
NASA engineers evaluate the students' work by trying out their ideas in a simulated spacewalk, so that they and the students see what works and what needs tweaking. It's a unique educational experience.
Even though we had some technical issues while testing, it was very surreal to see our tool being tested at Johnson Space Center. My favorite part about working with the team is that everyone was very excited to learn and also share what they know. We all come from different majors and different backgrounds, so by the end of the cycle, everyone knew a little bit about rocks or about programming or got out of their comfort zone by presenting our project.
It also helped with interpersonal skills, learning how to work within a team, improving my technical communication. I can talk about systems and software, helping me be more confident in my abilities.
It's great to see them grow. It's great to see them collaborating with each other, collaborating with subject matter experts to make their designs more effective or more efficient.
The research gathered in Suits benefits NASA too, as it develops its own designs for possible graphic displays. It's future-forward work that is needed now.
When I entered the field of augmented reality for EVA displays, there was about one paper that I could reference. What Suits provides to the engineers at NASA is really the ability to explore many different designs, to explore many different concepts, and really have a think tank, if you will, for what the future of these displays really look like.
All the hard work, testing, and learning points to a brighter future using this technology.
It's an amalgamation of doing something that I love and also seeing the value that would come off of it in the long run. And I think that's the same for most of my peers as well who worked in this project. You could see some real, genuine passion in working on this, and everything shows that we really want this to work. We really want tech and space exploration to be the next big thing. And that was super satisfying and fulfilling to me and to the team as well.
Building this software for these displays is like giving the crew members superpowers, and that's something that I love about it, but also getting to engage with academia and the talent that we have in academia and in universities. That's what we need to see, and the creativity that comes from it to make these tools the best that they can be. With NASA Suits, we want to see your vision. Your vision.
With NASA Suits, we want to see your vision.
Your vision.
This is NASA Suits, and we want to see your vision.
Visit stem.nasa.gov/Artemis and see how you can join one of NASA's mission-related student challenges.
International Space Station crew members spend some of their time on station maintenance, some on science activities, and some of it sharing the experience of flying in space with folks on Earth, including students studying the fields of science, technology, engineering, and math. In this new demonstrations video, Expedition 65's Shane Kimbrough describes how crew members use their senses in space and how those senses adapt to being in weightlessness.
Hello, my name is Shane Kimbrough, and I'm an astronaut living and working up here on the International Space Station. In this demonstration, I'll be talking about the 5 main senses we have and how we use them up here on the station. Let's go check them out.
As humans, we have 5 senses that let us observe the world around us. These senses are sight, taste, smell, hearing, and touch. Our senses help us determine whether or not we like something, but they also warn us if something is wrong. Sometimes our senses pick up very good things, like the smell of fresh-baked cookies or the taste of yummy pizza. Other times, our senses may warn us of danger, like the smell of something burning or the feeling of something hot. Let's go through the 5 senses and talk about what we may observe with them up here on the station.
Sight.
The sense of sight allows us to see the world around us, or in my case, space. Here on the station, one way we use our sense of sight is to see different experiments we are working on, so we can report the results back to Earth. Some astronauts have noticed that their sight changes a little after living in microgravity aboard the station. Scientists are helping to fix this by conducting research up here on astronauts like me.
Taste.
Our sense of taste comes from our tongue, and it tells our brain what kind of food and nutrients we are putting into our body. We can tell when something is super sweet or very salty because of this. Because of fluid shifts on the space station, sometimes our noses can be a bit stuffy and it can be harder to taste food. So, lots of us love to add hot sauce to many of our meals to amplify the taste.
Smell.
Just like with taste, sometimes our sense of smell can change up here in microgravity as the liquids in our body move around. Once our bodies have adjusted to microgravity, the space station has a very distinct smell.
Hearing. In terms of hearing inside the space station, there is constant noise coming from the different machines that keep our air flowing and the experiments running. Our sleeping quarters block some of the noise though, so we're able to get a good night's sleep each night. What do you think you would hear outside the space station? Well, you better be wearing a spacesuit, so you'd be hearing the fan noises inside the spacesuit. But if somehow you were able to be outside of that spacesuit, you would hear absolutely nothing, because sound cannot travel in space, because it has no air to travel through.
Touch.
Usually when you think of touch, you think of observing how things feel with your fingers. Since we are floating, we are constantly having to touch and grab onto objects, either using our hands or our feet. You can use your feet to walk up here if you carefully hook them under handrails as you go. But this is pretty challenging, so we like to use our hands more than our feet while we're up here. We will often use our hands to move along and carry objects with our legs. Thanks for learning about the 5 main senses with me today. Start thinking about your 5 senses and how they help you observe and adapt to your environment down on Earth. See you next time.
The International Space Station provides a spot to keep an eye on the changes occurring here on the planet. But it turns out it does more than that. Cosmonaut Sergei Kriklyov, a member of Expedition 1 more than 20 years ago, and later commander of Expedition 11, says the more than 800 days spent in space over his whole career helped him develop his perspective on the power of human beings from all over the planet working together in space.
I read a lot of science fiction. I think good science fiction, and because of that I thought, well, that's probably an interesting thing to spend my life on. First, on orbit, you start to feel weightlessness, and I remember first time looking outside, I was amazed to see a curved horizon, because before that, although we theoretically knew that we are on the globe, but from orbit you already see curvature of the Earth, and that was first surprise. Again, I knew it, but to see with your own eyes that you have pretty thin layer of atmosphere that protecting us, that's another interesting experience. When you look down, you have some kind of blue filter. And this blue filter make all colors actually not so distinct. So really, green is not so green, it's more like bluish green. Blue is more blue because again, we have more blue from atmosphere. And where we have really bright colors is on horizon, especially during sunrise and sunset. That's where we have a lot of brightness and a lot of colors. when you look down, I realized that it's a little more difficult to find things on the surface than when you do it on the maps. Because on the maps you have borders, but in space you have no borders and you have only natural rivers, mountains, beaches, water and forests. So you start to understand that in many cases our separation on the Earth is more artificial. Naturally, we are living on the same surface. So you start to feel that we are more united. On the ground, we live in a different country with different view on some things, but being in space, we're all exposed in a harsh environment. We all have about the same motivation to go up, and majority of us, and actually I would say all of us who was in space, start to care about environment, about Earth, about people on Earth. And you start to feel kind of brotherhood. We live on the same Earth, with the same bigger than station, but still spacecraft that are flying through the space. And we have joint problems together, environmental, technical, philosophical sometimes, but we need to solve these problems together, and that's the best way how to do that. I think what we do in space together is a good example how people need to live on the ground. I know that people sometimes start to argue with no good reason for that, but again, especially when you're in harsh environment, you rely on each other, you try to help each other. That's how we live in space, and that's probably can be a good example for people on the ground. I'm happy that all this political turbulence doesn't affect us too much. We try to keep this area protected and keep this good example to show maybe politicians and maybe other people in my country, in your country, showing that that's really how we need to live.
Would you like another look at any of these stories? Well, you can. You can find them all on YouTube and Facebook, along with a lot of other great features on a whole variety of NASA topics. And if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, a weekly show with interviews about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan talks with a scientist working on an experiment now perched on the outside of the International Space Station that is measuring how the Earth breathes. Go to nasa.gov/podcasts for this week's episode and all the previous episodes and the full library of all NASA podcasts, which can also be found on Apple Podcasts, Google Podcasts, and SoundCloud.